If you have a chiral compound, then it has a pair of enantiomers. And now your task is to draw these pair of enantiomers, this pair of enantiomers, or if you have multiple molecules. The easy way of doing it is you either replace wedged bonds and hashed bonds or vice versa, or draw the mirror images side to side. So I'm about to show you. First thing you need to do is you need to find the stereogenic center. Can you find it? Which carbon has 4 different groups attached to it? That includes, of course, atoms. Not this one. Not this one. Of course, O doesn't apply. So only this one right here. This carbon right there. So this carbon has, again, 4 different groups. So find the stereogenic center. The next thing is you need to draw the tetrahedral, okay, or draw the 3D structure. If you remember, that's called tetrahedral. You learned that in Gen Chem. Talked about it this semester. So basically, this is what you do. And let me move this up because I need to. So you start with C right here. And you would do the following. You'd have 2 lines. They're about 109.5 degrees away. You can start with whatever you want, but I'll show you a quick way here. So what you need to do is, again, so we put the BR, let's say, on the top. What are the 4 different groups? You have an H, you have a CH2OH. And if you recall, there's a hatched line or a hatched wedge, which means it's in the back. We'll put the H there, and then of course there's a CH3 in a solid wedge. Now, one way of making the solid wedge, less work for you to fill in is to make it thinner rather than make it, like this thick. So you just make it thinner. And then that's, of course, the CH3. So you have the H, the CH2OH, and then the Br. So here it is. Of course, we will see this in the skeletal structure. So now what you need to imagine is you need to put a mirror image, the mirror image of this. So you draw kind of like a, let me use a different color, we use a dashed line moving down like this. And you need to imagine now this being with its reflection. So take a minute, think about it. How would the reflection look like? You can pause and then you can check again. So what would happen is that the BR stays the same, nothing happens on the top. This one now would be closer to this side. Let me move this a little bit so I can have more space here. The CH2OH, again, nothing happened here. So of course we do it this way because remember the attachment is the C, so you want to make sure it's attached this way. But anyway, just pay attention, it's this group. And then you have the H still in the back. And of course, the solid wedge is CH3 right there. So these are enantiomers of each other. These are mirror images, enantiomers, mirror images that are not superimposable. So when we say enantiomer, you have to couple it with mirror images that are not superimposable, which makes them chiral. Or there's another way of doing by drawing the enantiomer of this. What you can do is you can just switch two atoms. Now, I'm talking about in reference to this. If you switch two atoms of this, you're going to go back to what you started with. So be aware of that. So we're talking about switching two atoms of this. So what I can do is I can just simply say, here it is. And let me just raise this up. I can keep the H and the CH3 the same. And what I can do is I can switch these two, the Br and the CH2OH. So I can put the CH2OH and the Br down here, and that should be an enantiomer of the other one. Again, do not do two switches. If you switch twice, again, if you switch twice, you will go back to what you started with. So switch, in this case, switched two groups. Very well. So how do we now label our stereogenic centers with R or S? So we have different configuration. We have R and we have S. And that's a one way of distinguishing between the enantiomers. If we just say enantiomer 1 and enantiomer 2, that's not much information, like this one or even that one, right? So we cannot just say enantiomer 1 and enantiomer 2. That's simply just too confusing. We need to get a way or find a way of determining which, how are they different. So we assign them a configuration. And the configurations, this is a convention, is the R or S. The R or S, R or S. So R is a clockwise arrow, meaning it goes from, it comes from Latin for rectus, which means to the right. S is counterclockwise, and it's from sinister in Latin, which means left. Left-handed people were thought to be possessed. That's why the word sinister. So S and R, S and R. I'm going to give you an example before we actually learn how to do it, because we need to assign priorities and then we can draw the arrow. The example is the following. So imagine, I have my C here. This is priority 1. This is priority 2, just giving you an example. This is priority 3. And this is priority 4. Then the priority goes 1 to 2 to 3. So that would be what? Clockwise. Or R. If I do the opposite, where I have now This would be 1 now. We keep the 3 and the 4. Again, just giving you an example. Not every example is going to look like this, but this is the concept here is you draw your arrow. So now it goes from 1 to 2 to 3. So clockwise or counterclockwise. So this is counterclockwise, which is what we call an S configuration.